Hello, in this video we're covering recursion. Recursion is typically a hard concept at first for beginning programmers, so make sure to get help as you need it and make sure to really understand things and go through and draw it out if you need. So example 1 says, below is a for loop that counts down from 10 to 1, rewrite it using recursion. So if we run that, we see it does count down from 10 to 1. You may also have not seen this syntax before, range with a third argument here, and that's the step argument to the range function. So we're normally used to giving range two values, the start and the end, but we can also provide a third, and that is the amount that we go up or down by each time. So in this case, we're going from n, which is 10, to 0, and that's non-inclusive, 0, so we go to 1. And we also go down by 1 each time. So let's comment this out. And then we'll begin making our recursive function. So we'll say def countdown with parameter n. And we know that once we hit 0, we want to stop. Because like in the last one, once we hit 0, because of the inclusivity of the range function, we stop at 1. Because we're going from n to 0 exclusive. So let's say if n equals 0, we'll just return, we'll stop the function. Otherwise, we do want to print n each time. And then here is the recursive case. So above we had the base case. N equals 0 will return, which stops the function completely. We'll say for the recursive case, countdown. And then here's the sort of tricky part. We pass in n minus 1 to the function we're inside of. So let's just run this first to make sure it works, which it does. It goes from 10 to 1. And now let's break down what's going on here. So we originally say countdown is 10. We hop into the countdown function, and n is 10. So we're checking if 10 equals 0. Well, that's not true, so we don't do anything inside of the if statement. Then we'll print 10. And then we'll call countdown with 10 minus 1, which is 9. Go back up, countdown with n equals 9. Well, 9 doesn't equal 0, so we print out 9, and we go again. Countdown with 9 minus 1, which is 8, and so forth. All right, our next example says to implement a factorial function recursively, and this is a pretty common problem seen for recursion problems. Also remember that 0 factorial is 1. We won't get into why, but we'll follow that rule today. Also, if you don't know about factorials, it's just the number, the current number that you're taking the factorial of, signified by an exclamation point, multiplied by all the numbers below it down to 1. So 4 factorial is 4 times 3 times 2 times 1. All right, so we'll start the function and we'll say def factorial, and we'll pass in n again. And we know if we have 0 factorial or 1 factorial, the result is just 1. So that's our base case. If n is 0 or n is 1, we want to return 1. And that stops our recursion because it's the base case once it's reached. And then the tricky part is now to actually do the recursive case. So we'll return the recursive case. You don't have to call the recursive case without a return like we did last time with the countdown. We can return it. We'll say n times, so we want the current n times all the lower n's. Because in this example I did above, 4 factorial is 4 times 3 times 2 times 1. Well, 3 times 2 times 1 is 3 factorial. So we can say that really equates to 4 times 3 factorial, right? So this makes sense. Why it can be recursive is because we can say n times factorial n minus 1. So let's try this out. Print factorial of 4, and we get 24. because 4 times 3 is 12, times 2 is 24, times 1 is 24. And if you wanted to try this with a few other numbers, it would work as well. It would also work even with the base cases. If we said factorial of 0, it would immediately go to 1. So this is a lot to unpack, even though it's only 4 lines. And just to reiterate, we have the base case, and then we have the recursive case inside of a return statement as well. So each time we are saying n times the factorial of n minus 1. All right, that's it for recursion. As mentioned, please get help on recursion if you need it. It is pretty confusing at first, and that's totally fine because it's just hard to visualize. I would definitely recommend drawing it out and keeping track of where you are in recursion if you're going through, say, a test problem or a worksheet problem on this. It will definitely help just to write it out.